Welcome to the deep dive. Today, we're going to be looking at some research on project-based teaching methods in Intro to AI courses. And, whether you're a student, an educator, or just someone who's curious about the future of AI, I think you're going to find this really interesting.
Yeah, AI is such a hands-on field. This research really digs into why that practical experience is so crucial, even for beginners.
Okay, so let's start with the basics. Why is this research even necessary? What's wrong with the way we've been teaching AI traditionally?
Well, think about it. You can spend hours listening to lectures about algorithms, but until you actually start building something with those algorithms, it can be really tough to grasp how they actually work.
Right, so it's kind of like reading a cookbook versus actually getting in the kitchen and cooking right.
Exactly. Traditional AI teaching often gets stuck in the theory, and that's where project-based learning, or PBL, comes in.
All right, so what exactly is PBL and why is it so well suited for AI education?
It's all about learning by doing. Instead of just passively absorbing information, students engage in real projects that require them to apply what they've learned. And this is especially important for AI because it's such a rapidly evolving field.
So instead of relying on textbooks that might be outdated, students are out there researching the latest techniques and tools.
Exactly. And the research we're diving into today actually shows that PBL leads to better grades and knowledge retention compared to traditional methods.
That's impressive. But better grades are just one piece of the puzzle, right? What else did the researchers find?
Well, one of the most interesting findings is that PBL helps students develop practical AI skills. Things like problem-solving, programming, data analysis. The skills employers are actually looking for in the real world.
That makes a lot of sense. It's one thing to understand the concepts in theory, but it's another to be able to actually put them into practice.
And this is where the research gets really interesting. They actually compared two groups of students. One group learned through PBL, and the other received traditional instruction.
So they were trying to see if there was a measurable difference in how the two groups learned. What did they use to track the students' progress?
Well, to measure the effectiveness, they collected data in a few different ways. They looked at academic performance, things like test scores and project grades, but they also conducted practical skills assessments.
So they actually tested to see if the students could apply what they had learned.
Yes. They had to solve real-world problems and demonstrate their understanding of AI concepts in a practical setting. But it wasn't just about hard skills. They also collected a ton of student feedback through surveys and even in-depth interviews to understand their learning experiences.
It sounds like they really wanted to get a holistic view of how these different teaching methods impacted the students. So what did they find? Were there any significant differences between the two groups?
The results were actually pretty compelling. The students who learned through PBL consistently outperformed their peers in the traditional learning group. And I'm not just talking about slightly better, we're talking significantly better.
Wow, that's quite a difference. So the PBL approach actually helped them achieve a deeper understanding of the material.
It seems that way. And remember, it wasn't just about grades. They also demonstrated greater development of those essential practical AI skills that are in such high demand today.
So they were not only able to understand the theory, they could also apply it to real-world situations.
And on top of that, the PBL students actually reported more positive learning experiences. They felt more engaged, more curious, and they could see the real-world relevance of what they were learning, which is something that could be a challenge with more traditional teaching methods.
It makes sense. When you're actively involved in a project and you can see how it connects to the real world, it's bound to be more engaging. But I'm curious, what kind of projects were these students working on? What does PBL actually look like in an AI classroom?
Well, the research paper dives into a few really exciting project categories, from machine learning projects to robotics, and even some that focused on the ethical and societal impact of AI.
Hold on, ethics in an intro to AI class. That sounds pretty advanced.
It might sound surprising, but it's becoming increasingly important to incorporate ethical considerations into AI education from the very beginning.
That's a great point. It's not enough to just understand the technical aspects of AI. We also need to think about the potential consequences and ensure that we're developing and using AI responsibly.
Exactly. And PBL can provide a framework for students to engage with these complex ethical questions in a meaningful way.
So they're not just learning about AI, they're also learning how to be responsible AI practitioners. That's fantastic.
Absolutely. And this is one of the things that makes PBL such a powerful approach for AI education. It equips students with both the technical skills and the critical thinking skills they need to navigate this rapidly evolving field.
So we've established that PBL seems to have some pretty incredible benefits, but I'm sure it's not without its challenges, right?
Of course, implementing PBL effectively requires careful planning and resources. It can be more demanding on instructors, and it often requires a shift in mindset from both teachers and students.
That makes sense, but based on the research, it sounds like the potential benefits outweigh the challenges.
I think so too. And we're just scratching the surface here.
That's right. We're only halfway through our deep dive into PBL for AI education. Stay tuned for part 2, where we'll explore even more insights from this research and discuss how you can apply these concepts to your own learning or teaching journey. Welcome back to the deep dive. Last time we started digging into this research on project-based learning for AI, and it sounds like it has some serious potential.
Yeah, it definitely does. And one of the things that really stood out to me in the research was the importance of choosing the right projects. It's not just about picking something that sounds cool. It's about aligning those projects with clear learning objectives.
So before you even start thinking about building robots or writing code, you need to figure out what you actually want students to learn from the experience.
Exactly. What specific skills or knowledge are you hoping they'll gain? Once you have those objectives in mind, you can start brainstorming projects that will effectively target those areas.
That makes sense. Otherwise, it's easy to get sidetracked by all the exciting possibilities in AI and end up with a project that might be fun, but doesn't actually contribute to meaningful learning.
Absolutely. You want to find that sweet spot, a project that is challenging enough to push students outside of their comfort zones, but not so overwhelming that they become discouraged.
Okay, so let's say you've identified your learning objectives. How do you go about choosing projects that strike that perfect balance between challenge and engagement?
Well, the research offers some great suggestions. One idea is to start by identifying the core concepts you want students to grasp. For example, if you're teaching an Intro to AI course, maybe you want them to understand the basics of machine learning or natural language processing.
And then you would look for projects that allow them to apply those concepts in a hands-on way.
Exactly. Let's take machine learning as an example. Instead of just lecturing about algorithms, students could build a simple image classification model, something that could distinguish between different types of objects in pictures.
So they would actually be creating AI, not just learning about it in the abstract. That sounds a lot more engaging than just reading a textbook.
It is. And by going through the process of building and training their own model, they'll gain a much deeper understanding of how machine learning works. But remember, relevance is key. The research also emphasizes choosing projects that connect to students' interests or real-world problems they care about.
That's such an important point. If students are passionate about the project, they're going to be much more motivated to learn and put in the effort.
Think about it. If you're a student who's passionate about environmental issues, how much more engaging would it be to work on an AI project that uses machine learning to analyze pollution levels in a local river than something generic and less connected to your interests?
Okay. I'm sold. Connecting projects to real-world issues is definitely the way to go. But I'm also wondering about the role of the instructor in all of this. How much guidance should they provide? It seems like it would be tricky to find the right balance.
It definitely can be. The research talks about the importance of scaffolding, which essentially means providing the right level of support to help students succeed without doing the work for them.
So you're creating a supportive structure like a scaffold around a building, but the students are still the ones doing the building.
That's a great analogy. It might involve breaking down a complex task into smaller, more manageable steps. Or maybe providing regular check-ins to answer questions and offer feedback, guiding students without giving them all the answers.
So it's about creating a learning environment where students feel empowered to explore, experiment, and even make mistakes along the way.
Exactly. Making mistakes is a natural part of the learning process, especially in a field as complex as AI. It's how students respond to those challenges that really matters.
So the instructor's role is to help them develop resilience, problem-solving skills, and the ability to learn from those mistakes.
Precisely. And these are skills that are valuable not just in AI, but in any career path in today's rapidly changing world.
It's about preparing them for jobs that might not even exist yet. So we've covered choosing the right projects and providing the right level of guidance. What about assessment? How do you evaluate student learning in a project-based setting?
That's a great question. Traditional exams and quizzes might not be the best way to measure understanding in PBL. It's more about the process and the application of knowledge, wouldn't you say?
Absolutely. So how do you capture that?
The research recommends a more holistic approach. This might involve evaluating the final project outcome, But it should also include factors like teamwork, communication skills, and the student's ability to solve problems and reflect on their learning experience.
It's like looking at a portfolio that showcases not just the end product, but the entire journey of learning and growth.
Exactly. This kind of assessment not only gives instructors a more complete picture of what students have learned, but it also provides valuable feedback that students can use to continue improving. But we're only halfway through what this research has to offer.
That's right. There's still so much more to uncover in our deep dive into project-based learning for AI education. Stay tuned for part 3, where we'll look at specific examples of what this looks like in practice and what it all means for you, the listener. Welcome back to the deep dive. We've been unpacking all this research on project-based AI learning, and I'm really excited to see how all of this theory actually translates into real-world projects.
Yeah, well, I think you'll be impressed by some of the examples that are highlighted in this research. There's a lot of creativity out there.
Okay, so where do we start? What are some of the most common or intriguing project areas that students are tackling with PBL?
Let's begin with one that's probably on everyone's mind these days: machine learning.
Of course. It seems like machine learning is everywhere, from, those personalized recommendations we get online to self-driving cars. It's almost like magic.
Yeah, it can feel that way, but the reality is that these quote-unquote magical systems are built on algorithms and data, and project-based learning can really help demystify that process.
So what does a machine learning project look like for a student who is just starting out?
Well, there are so many possibilities. Imagine a student building a system that can recognize different breeds of dogs in images, or one that can analyze movie reviews to predict whether people will like a film or not.
Okay, those are pretty cool applications, but how would a student even begin to tackle something like that?
Well, the beauty is that there are so many resources available these days. Students could use platforms like TensorFlow or PyTorch, which provide the building blocks for creating these types of AI systems, and there are tons of free data sets online that they can use to train their models.
So they're not just learning about AI, they're actually creating it. That's a pretty empowering experience, especially for someone who is new to the field.
Exactly. And by going through that process of building a model, testing it, refining it, that's where the real learning happens. It goes way beyond just understanding the theory.
Okay, so we've got machine learning covered.
Yeah.
What other areas are ripe for project-based learning in AI?
Well, if you're someone who likes to tinker and build things, robotics is another really exciting avenue. The research mentions students building robots that can navigate mazes, play games, even assist with tasks around the house.
Wow, it sounds like a scene out of a sci-fi movie. But seriously, building a robot from scratch seems pretty ambitious, especially for beginners. Is that realistic?
It might sound daunting, but there are robotic kits and platforms that are designed specifically for educational purposes that make it a lot more approachable. And the process of building a robot, even a simple one, involves so many valuable learning experiences.
What kind of skills would a student develop through a robotics project?
Well, they'd gain experience with programming, problem solving, even basic engineering principles. They'd learn about sensors, motors, how to translate an idea into a physical machine. It's a fantastic way to integrate different disciplines and bring those concepts to life.
I can see how that would be really engaging. It's not just about writing code on a screen. It's about seeing your creation interact with the physical world.
Exactly. And the research highlights another area that is often overlooked in traditional AI courses, but is becoming increasingly crucial: the ethical and societal implications of AI.
We touched on this earlier, and I think it's so important. It's not enough to just build powerful AI systems. We need to think critically about how they will be used and what impact they might have on society.
And project-based learning can help students grapple with these complex issues in a meaningful way. Imagine a project where students have to design an AI system for a specific purpose, like healthcare or transportation. But they also have to consider the potential ethical dilemmas and propose solutions.
That's a great example. It's not just about the technical skills. It's about responsible innovation and anticipating potential consequences. So we've covered a lot of ground here. What would you say is the biggest takeaway from this deep dive into project-based learning for AI?
For me, it's about recognizing the power of active learning and the importance of connecting those theoretical concepts to real-world applications. Project-based learning isn't just a fun way to learn about AI. It's a powerful tool for equipping students with the skills they need to thrive in a future that will be increasingly shaped by AI.
I couldn't agree more. And whether you're a student, an educator, or simply someone who's curious about the future of AI, I think there's a lot we can all take away from this research. It's an invitation to think differently about how we learn and teach and to embrace the power of hands-on experience in unlocking the potential of AI.
Well said. And if you're feeling inspired, why not think about an area of AI that interests you and brainstorm a project that you could tackle? You never know, it could be the beginning of your own AI learning journey.
That's all for our deep dive into project-based AI learning. Thanks for joining us.